Now we are going to learn how to construct minimum cost spanning tree using Kruskal algorithm in graph data structure. Kruskal algorithm which builds minimum cost spanning tree T by adding edges to T one at a time, one edge at a time. How to select the edges based on non-decreasing order of their cost. Here we have to check the conditions. First one, this algorithm select the edges. If select the edges, it does not form a cycle with the edges that are already in T. Second one, the given graph is connected one and it has greater than 0 vertices. Okay, let us see one example. We can list out the edges in the given graph in non-decreasing order of their weight or cost, such as 10, starting with 10, 12, 14, 16, 18 up to 28. Okay, this table that shows the order in which the edges are considered for adding minimum cost, the resultant graph and the tree is minimum cost spanning tree, as well as the action to be taken in the construction of spanning tree. For example, the minimum cost, the first minimum cost edges 0, 5. Select this edge. Here we have to check the condition as the tree and the edges that does not form no cycle, and finally the constructed minimum spanning tree has n-1 edges. Okay, first one, the least minimum cost edges 0, 5. I can select this edge for adding this tree 0, 5. The weight is 10. Here it does not form any cycle with the tree. So added into the tree. Second, 2, second minimum cost weight is 12. The edge is 2, 3. It also does not form any cycle with the tree. Then 2, 3 also selected for adding in our tree. The weight is 12. Here it also added. Next, 1, 6. 1, 6, the weight is 14. Okay, so added. Next, select as 1, 2. Okay, it also does not create a cycle. The weight is 16. Okay, added to our tree. 3, 6. 3, 6. Okay, it forms a cycle. 3, 6 forms a cycle with the 1, 6, 1, 2, 2, 3 edges that is already in this tree. Okay, so we discard that edge 3, 6. Next, select 3, 4. 3, 4. Okay. Okay, 3, 4. The weight is 22. Is added to our tree. Next, 4, 6. Okay, 4, 6. It forms a cycle with 1, 6 edges in the tree. So we discard that edge. Next one, 4, 5. 4, 5. Okay, the weight is 25. Is added to our tree. Okay, it generates, it contains n-1 edges. The vertex has 7 vertex. The edges has 1, 2, 3, 4, 5, 6. It contains 6 edges. Okay, in the last edge is not considered for adding in this tree. Minimum cost is 10 plus 25 plus 22 plus 12 plus 16 plus 14 as 99. Now we will see its algorithm. Initially, our minimum cost spanning tree as empty one. First, we have to check the condition as the minimum cost tree, the less than n minus 1 edges and edge set is not empty. Okay. The statements are: first, we should select or choose a least cost edge, least cost, that is least weight edge V, W. So V, W from edge set. Second step, then delete that edge V, W from edge set E. If V, W does not create a cycle in tree, in minimum cost spanning tree, then add that edge V, W to T. Otherwise, discard that edge V, W. Now finally, we have to check another one condition, that if our minimum cost spanning tree contains less than n minus 1 edges, then printf no spanning tree. Big O of E log E computation time. This algorithm contains two major operations. First one, sorting edges. Second one, choosing and deleting operations. It takes big O of E log E computation time. It takes less time compared to sorting edges. So overall computation time is big O of E log E. Thank you.